Black holes and wormholes have long become a familiar attribute of many science fiction movies and series, where space travelers use them for instantaneous travel across the universe. But what do they actually represent? Hello, dear friends. In today's video, we would like to tell you about one of the most exciting mysteries of the modern world, wormholes. In this video, you will learn what they are, how they work, whether they really exist, and whether humanity can use them for space travel. Before we begin, we would like to ask you to subscribe to our channel and click the bell icon to be the first to see our new, interesting videos about the mysteries of the universe. The hypothetical wormhole is a kind of space-time tunnel that allows an object to move from point A to point B in the universe, not in a straight line, but by bending space. To make it easier to visualize this hole, take a simple sheet of paper, fold it in half, and pierce it. The resulting hole would be similar to that wormhole. It consists of two entrances called mouths and a tunnel called the throat. There is a theory that space in the universe may be like that sheet of paper, but with an adjustment for the third dimension. In other words, we are talking about 3D space, not a flat surface. The system remains roughly the same, but the entrances from two-dimensional circles would turn into three-dimensional spheres. Various scientists hypothesize that thanks to wormholes, travel through spacetime is possible. However, no one knows exactly what dangers wormholes may pose and what might actually be on the other side. But before, let's figure out where we first heard about them. In 1935, physicists Albert Einstein and Nathan Rosen, using the general theory of relativity, suggested that there are special bridges through spacetime in the universe. These paths, called Einstein-Rosen Bridges, connect two completely different points in spacetime by theoretically creating a curvature of space that shortens the journey from one point to another. These so-called Einstein-Rosen Bridges, representing intricate spatial structures, later came to be known as wormholes, proposed by physicist John Wheeler, who also introduced the term black hole. Again, hypothetically, any wormhole consists of two entrances and a throat, that is, the tunnel itself. Likely, the entrances of a wormhole have a spheroidal shape, and the throat can be either a straight segment of space or a spiral. The general theory of relativity mathematically proves the possibility of the existence of wormholes, but none has been discovered by humans so far. The difficulty lies in the presumed immense mass of wormholes and gravitational effects that simply absorb light and do not allow it to reflect. This means that visually, wormholes look very similar to black holes. Both of these objects are two different types of solutions to the equations of general relativity. The distinguishing feature of a black hole is the presence of an event horizon beyond which nothing can escape due to a strong gravitational field. A black hole must have an event horizon, but it does not necessarily connect different regions of spacetime or different universes. On the other hand, the attribute of a wormhole is precisely the connection of such areas, but it may not have an event horizon. And if a wormhole does have one from the outside, it looks exactly like a black hole. In science fiction, it is often depicted that the main characters travel through wormholes. But in reality, such a journey is not as simple as portrayed in movies and described in science fiction literature. The first problem that arises in the possibility of such travels is the size of wormholes. It is believed that the very first wormholes were very small, ranging from 10 to 33 centimeters, but due to the expansion of the universe, there is a possibility that along with it, the wormholes also expanded and increased in size. Another more global problem related to wormholes is their stability, or rather, instability. According to the Einstein-Rosen theory, wormholes would be useless for spacetime travel because they collapse very quickly, meaning they close. However, more recent studies on these issues suggest the existence of exotic matter, which allows wormholes to maintain their structure for a more extended period. This exotic matter, which should not be confused with dark matter and antimatter, consists of energy with negative density and colossal negative pressure. Mention of such matter is only present in some vacuum theories within the framework of quantum field theory. Nevertheless, theoretical science believes that if wormholes contain a sufficient amount of this exotic energy, Either naturally occurring or artificially created, it would create the possibility of transmitting information or even objects through spacetime. These hypotheses also suggest that wormholes can connect not only two points within one universe, but also serve as entrances to others. Some scientists believe that by manipulating one entrance of a wormhole in a specific way, time travel might become possible. However, renowned British cosmologist Stephen Hawking, for example, argued that such use of wormholes is impossible. Nevertheless, some scientific minds insist that if stabilization of wormholes through exotic matter is indeed possible, it could provide a safe means for humans to travel through such wormholes. And thanks to ordinary matter, if desired and necessary, these portals could be destabilized back. Unfortunately, practical use of wormholes for reaching distant cosmic objects is not currently considered. Their properties, varieties, and potential locations are known only theoretically, though even that is a significant amount of knowledge. After all, we have numerous examples of initially speculative theories leading to the emergence of new technologies that fundamentally change human life, such as nuclear energy, computers, mobile communication, and genetic engineering. Initially, the idea of wormholes seemed entertaining but impractical due to the belief that they collapse before they can be observed. However, with the advent of exotic matter, the situation has changed. Some scientists suggest that wormholes could reach enormous sizes, and that at the center of our galaxy, there might not be massive black holes, but rather the mouths of such wormholes. Thus, it can be said that humanity is yet to unravel the fascinating secret of this phenomenon, but one thing is for sure, it won't be a dull endeavor. Thank you very much for watching. If you enjoyed this video, don't forget to like it and subscribe to the channel to stay tuned for new interesting videos about space and the universe. Feel free to comment on what you would like to learn in the next video. Thank you, and see you next time.